طيب، بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله الأمين. السلام عليكم ورحمة الله تعالى وبركاته. As we have seen that in a packet switch networks, typically when the users are statistically multiplexed, there is no concept of admission control. Any users can submit his data to the packet switch. If the combined output rate, Y, of all the users exceeds the channel capacity, R, then the packet gets buffered in the queue. And if the length increases the buffer capacity, then the packet may get dropped. So as a result, there is neither a control on the queuing delay nor a control on the packet loss. However, the network will make every attempt to transmit the packet in the best possible manner, and therefore the packet switch network is called best effort networks. On the other hand, for the real-time services, we want certain guarantees or certain quality of service guarantees, either on the packet loss or on the delays or on both. And then we were trying to just see how these or those quality of service guarantees can be given in a statistical multiplexer-based multiplexing. So I was just explaining you that here is a statistical multiplexer that you have seen. There are 1 to m users which have been multiplexed here, and the combined output rate is Y. So we had considered that each of these users have the data rates R1, R2, and so on up to Rm. These data rates, remember, are fluctuating. They are bursty in nature. They are not constant bit rates, but they are variable bit rates. And each of these data rates density functions is denoted by Fri, which typically may look something like this, that have just shown here in this graph. The bit rates versus the probability function. This is just an arbitrary realization. The density functions may vary from one user to another user. Now, whenever we have to give a quality of service guarantees, we have to consider some kind of an admission control. Now, let us consider a hypothetical admission situation where this will not be there in practice. But for the time being, let us consider a hypothetical situation where each user knows his probability density function. That means each user knows his curve looks like. So what we are saying is that each user can submit its density function to the network. Now let us say that these are m users. Each of the user has given its traffic characteristics to the network. Now the network's problem is that whether to admit the user or not. That means the network wants to determine that how many such number of users can be admitted such that the packet loss remains below a certain tolerable limit. So we are considering a situation where there are no delays. Let us say there are 0 queuing delays, but each of these M users can tolerate certain packet loss. So now, what we are saying that each of these users have submitted their density functions, that is FR1, FR2, up to FRM, and so on. The network determines what is the density function of the output, that is Y, which is actually equal to R1 plus R2 plus up to Rm. Now, given the density function of each of these individual users, the network can determine the density function of Y by simple convolution of the density functions of these individual bit rates. So the network can determine what is FYY. Now, from this density function, FYY, we can easily determine what is the probability that Y will exceed R, where R is the output link capacity. So this can be determined by determining FYY. The moment it happens that Y exceeds R, there will be a packet loss. Now, if this packet loss is less than or equal to some tolerable limit, let us say delta, then we can admit all the M users. So a typical quality of service QoS mechanism would work something like this, that each user submit its probability density function to the network. Now, in this example, we have shown that the user 1 submits its density function FR1. User 2 submits its density function FR2. So I'm saying user 1 submits its density functions FR1, user 2 submits its density function FR2, and so on. By convolving these different density functions, the network can determine that what will be the probability density function of the multiplexed output, which is Y, which in this case we have said FYY. From that FY, the network can determine what is the probability that the bit rate of the multiplexed output exceed the channel capacity, which is R. Now, whenever the multiplex output bit rate increases the channel capacity, there will be a packet loss because we have assumed that there are no buffers. If this packet loss is tolerable, then it is clear that all M users can coexist. If this packet loss is not tolerable, then the M users cannot be admitted. So in practice, how admission controls will work. So let us say first that there are no users. Then the user number one comes. The user number one gives his probability density function. From that density functions, clearly the network can determine whether that the output will exceed the channel capacity within tolerable limits. If it is within tolerable limits, then yes, the user number one can be admitted. Now, the user number two comes. The network asks him that what is its density function. So the user 2 says, okay, its density function looks like this. Then the network determines whether by admitting this multiplexed output, density functions is such that the multiplex bit rate is less than the channel capacity with a probability that is within tolerable limit. Then yes, the user number two can also be admitted, and so on. And after some times, when it is so happens that by admitting another user, the quality of service guarantee given to the other users in terms of packet loss is getting affected, or the quality of service guarantees given to this particular user is not met, then the user will be blocked, or he will not be allowed to transmit his data. Now, in such a manner, we can have a large number of users multiplexed in statistical fashion. Now, remember that if each of these users say that they cannot tolerate any packet loss, that is, the packet loss they can tolerate is 0 packet loss, and at the same time, they cannot tolerate any delays, that is 0 delays, then the admission control scheme will degenerate to a naive admission control scheme where the user can be admitted based only on the packet rates. So we are going to explain the admissions of the users to the network based on packet rates in the next video, inshallah. So stay tuned and see you soon in the next video session. Thank you very much for listening. Assalamu alaikum.